This question is from GATE 2014 Mechanical Engineering Paper Set 2, question number 50. A project has 4 activities P, Q, R and S as shown below. Activity P has normal duration of 3 days. It's the first activity, so there is no predecessor. Its cost low in rupees per day is 500 rupees per day. For activity Q, normal duration is 7 days. Its predecessor is P and cost slope is 100 rupees per day. Activity R has normal duration of 4 days. Predecessor is activity P and its cost slope is 400 rupees per day. And activity S has normal duration 5 days and its predecessor is activity R, cost slope is 200 rupees per day. The normal cost of the project is rupees 10,000 and the overhead cost is rupees 200 per day. If the project duration has to be crashed down to 9 days, the total cost in rupees of the project is dash. Let's see how this will be solved. So the first step is to draw the activity diagram. We'll start with the first activity, activity P, with a duration of 3 days. The second one is Q as well as R because both of them have their predecessor as activity P. So we can branch out from here, activity Q and activity R. Q has a duration of 7 days whereas R has a duration of 4 days. Last activity is activity S, which has the predecessor as R. So this is the last activity on this path. We'll directly connect it to the end node. Activity S has duration of 5 days. End node, this is the start node and the in-between nodes. For crashing, first we will determine the critical path. So let's see how many paths are available in this network, and then for each of the paths we'll calculate the duration of that path. First path that is available is from P to Q and then endpoint. So it is P to Q. Second path is P to R to S. So first activity P will be completed, then R and then S and then end of the project. Duration for the first path PQ is 7 plus 3, that is 10 days. And the second path it is 3 plus 4, 7 plus 5, that is 12 days. Clearly, path PRS is the critical path. So to crash the duration of the project, first we will have to consider activity with minimum cost low so that there is minimum increase in the overall cost of the project. So activity with the minimum cost low in the critical path is activity S. Why do we select only an activity in the critical path? Because if we try to reduce the duration of Q in the non-critical path, total duration of the project still remains 12 days. Although we reduce the duration of activity on the non-critical path, duration will still remain 12 days. It will take 12 days to complete the project. And that is why we select an activity on the critical path. So when we select activity S on the critical path, we will bring the duration to 10. Because if we go below 10 and we bring it to 9, this will become the critical path. And then we will have to again go to Q. So in first step, we will reduce the duration to 10 days and see what the total cost is. So first step, reduce or crash duration of S by 2 days. By crashing duration of S by 2 days, what will be the total cost? Total cost will be direct cost, which is given as 10,000 rupees, plus calculating the indirect cost in terms of number of days of the project completion, that is 10 days, into cost per day, which is 200 rupees. Plus, now for crashing activity S, we will have to incur extra cost. We will have to bear extra cost, and that cost will be duration by which activity is crashed, that is 2 days into cost slope of activity S, which is nothing but the extra cost that we will bear in order to crash the activity by 2 days is 200 rupees per day, which is the minimum among PR and S. And that is why we have chosen activity S to crash. This will be equal to, adding up all the terms, we get 12,400 rupees. This is the total cost after we have crashed activity S by 2 days. Now we have to crash the project duration to 9 days. Next, if we crash using this path, If we crash the activity Q by 1 day, because Q is having the minimum cost slope of 100 rupees per day, this duration will become 9 days. But still, this duration is 10 days because S is only crashed by 2 days. And that is why we will have to bring both the durations together to 9 days so that both will become the critical path and overall project duration will be 9 days. So now, in order to bring duration for this path to 9 days, we will have to crash S by 3 days. And for this path, we will have to crash Q by 1 day. Let's calculate the total cost after this crashing is done. So in second step, we are crashing Q by 1 day and S by 3 days. Let's now calculate the total cost. So total cost will be equal to, again, the normal cost 10,000 rupees plus the overheads depends on the project duration in days, which is 9 days, into 200 rupees per day, that is into 200 plus. Now for crashing activity Q by 1 day, we will have to incur an extra cost of 1 into 100. Cost slope of Q is 100 rupees per day plus 3 into cost slope of S is 200 rupees per day. This calculates to 12,500 rupees. So to crash the duration of the project to 9 days, bring down the duration of the project to 9 days, the total cost is 12,500 rupees. This is the minimum cost that will have to be incurred. Let's go back and fill in the answer. So the total cost of the project is 12,500 rupees. To learn in detail about crashing of networks, you can refer to the NPTEL video, Crashing of Networks, from the course of Principles of Construction Management. This course is taught by Professor Sudhir Mishra. He is from Department of Civil Engineering, IIT Kanpur. I hope this solution will help you clear your doubt. Thank you.